Assalamualaikum, my name is EDLIANA AQILAH. So let's start with the client background. Smart Cafe is a specialty coffee chain with 5 locations across the city. They've been around for 5 years and they are growing fast, planning to open 3 new locations within the next 18 months. They rely heavily on network-dependent technologies. They use POS systems for ordering process, customer Wi-Fi as a main attraction for patrons, online ordering for pre-orders and delivery, CCTV surveillance for security, and staff devices for inventory and scheduling. But here is the main problem. Their recent success has exposed serious weaknesses in their network. They urgently need a complete overhaul. So looking at the organization structure, Smart Cafe follows a clear hierarchy. At the top is the owner manager, overseeing 3 supervisors, the store manager, head barista, and kitchen supervisor. Each stakeholder has different needs from this network upgrade. The owner wants a scalable network for expansion. The store manager needs reliable daily operations. Cashiers and baristas depends on fast POS systems. Kitchen staff needs stable online ordering, and customers just want fast, reliable Wi-Fi. Now let's examine the current network infrastructure, which is where several challenges begin to emerge. The existing design is flat and lacks proper network segmentation. All devices, including POS terminals, staff tablets, CCTV camera, and Wi-Fi access point, are connected to a single switch and operate on the same network. As a result, business, critical systems, surveillance devices, and guest users are all share the same network environment, creating significant security and performance concerns. So the key issues with this setup include the absence of traffic separation between business operations and guest internet usage, a single point of failure caused by relying on only one router and one ISP connection, shared Wi-Fi access with a single password for all users, and the lack of centralized management. Since each cafe operates independently, monitoring, troubleshooting, and enforcing consistent security policies become much more difficult. So these problems fall into 3 main categories. The first one is security. The flat network exposes sensitive systems like POS and CCTV to attacks. The second one is reliability. There have been multiple outages. Any hardware failure or internet disruption shut down everything. The last one, scalability. The current design simply can support 3 new locations. So as you can see from the table, slow internet during peak hours cause POS lag and delay orders. No network separation expose POS and CCTV to attacks. A single point of failure means complete shutdown if the router fails, and uncontrolled Wi-Fi access make it hard to manage and revoke access. To address these challenges, we established 5 key network requirements. First, security. Internal business system must be fully isolated from guest traffic, ensuring that unauthorized users cannot access sensitive company resources. Second, reliability. The network should eliminate single point of failure by incorporating redundancy, achieving at least 99.9% uptime and enabling automatic failover within 60 seconds in the event of a connection outage. Third, performance. The infrastructure must provide fast and stable connectivity, with POS transactions completing in under 2 seconds and customer orders being processed within 5 seconds. Fourth, scalability. The network should be capable of supporting future business growth, including the addition of at least 3 new cafe locations within the next 18 months. Finally, manageability. Administrators should be able to remotely monitor, manage, and configure network devices across all locations from a centralized platform, improving operation efficiency and reducing maintenance efforts.
Assalamualaikum, I am DALILI HAIFA. I will present about network topology. For Smart Cafe, we propose a 3-layer hierarchical network topology as shown in the diagram here. Our proposed network architecture consists of 3 distinct layers. First layer is the core layer that serves as the high-speed backbone of our network. Think of it as the highway system that connects everything together. Next, the distribution layer acts as the traffic controller, managing routing between different network segments and enforcing security policies. Lastly, the access layer is where the end device connect. For example, POS terminals, staff computers, wireless access points, and CCTV cameras. This hierarchical approach provides scalability, improved performance, and easier network management compared to flat network topology. At the core layer, we are deploying enterprise-grade Layer 3 switch with 10 Gbps backbone connectivity. This ensures that high-speed traffic between different parts of the network flows without bottlenecks. we are implementing switch stacking and redundant power supplies to guarantee high availability. If one switch fails, the other can continue operating seamlessly. The core layer connects to our dual ISP setup, providing one redundancy that we'll discuss in more detail later. Next, the distribution layer is where the intelligence of our network resides. This layer 3 switch performs several critical functions. First, they handle inter-VLAN routing, allowing different departments to communicate while maintaining security boundaries. Second, they enforce access control policies through ACLs, ensuring only authorized traffic flows between segments. Third, they implement quality of service policies, prioritizing critical traffic like post-transactions over less time-sensitive traffic like guest Wi-Fi. This layer also aggregates traffic from all access switch, concentrating it for efficient routing. The access layer is where users and devices actually connect to the network. We are using managed switch with Power over Ethernet Plus technology. This is particularly important because PoE Plus can deliver both data and electrical power over a single Ethernet cable. This simplifies the deployment of wireless access points and IP cameras without needing separate power outlets. At this layer, we connect post terminals, staff computers, wireless access points for guests and staff, CCTV cameras, and kitchen tablets. For our branch office, we implementing a simplified two-tier design consisting of core and access layers only. For our branch locations, we have adopted a two-tier architecture. This streamlined approach is appropriate for smaller sites while still maintaining enterprise-grade functionality. Each branch connects to headquarters through secure IPsec VPN tunnels over unified fiber connections. This allows centralized management while keeping branch network secure. The design is scalable where we can easily add more cafe branch in the future without redesigning the entire network architecture. Moving on to logical network design, this diagram shows how we segment our network using VLAN technology where we create multiple virtual networks within our physical infrastructure. VLANs enhance security, reduce unnecessary broadcast traffic, and improve overall network efficiency. We have designed 6 distinct VLANs to separate different types of network traffic based on operational functions and security requirements. These VLANs allow us to isolate sensitive business resources from public networks. So here is our VLAN assignment table. VLAN 10 is our post system network. This is critical for payment processing and sales data, so we have assigned it at the highest QoS priority. VLAN 20 supports staff devices including PCs, printers, and mobile devices with medium priority. VLAN 30 provides customer Wi-Fi access with low priority where it is isolated from business systems. Moreover, VLAN 40 support our CCTV surveillance system with medium to high priority to ensure video feeds are not disrupted. VLAN 50 handles kitchen tablets and online ordering systems, also high priority because customer orders must flow without interruption. And lastly, VLAN 60 is our management network. It is restricted to administrative access only with the highest priority. Our logical design also shows dual ISP connectivity strategy where headquarters connects to 2 internet service providers. For primary, we use unified fiber at 500 Mbps, and for backup, we use Cellcom 4G or LTE at 100 Mbps. Both connections will terminate at our 40 gate firewall, which provide automatic one failover and load balancing. If the primary connection fails, traffic automatically redirects to the backup without manual intervention. This is to ensure continuous internet availability. Communication between VLANs is controlled by our layer 3 core switch through access control list. The SELs function as security filters. They define exactly what traffic is permitted between networks and what is blocked. For example, guest Wi-Fi users on VLAN 30 are restricted to internet access only. They cannot communicate with post systems, CCTV devices, kitchen system, or staff resources. This segmentation is crucial. If a customer's device is compromised, the attacker cannot move laterally into our business system. Other than that, Branch A and Branch B establish secure communication with headquarters through IPsec site-to-site VPN tunnels. These VPNs encrypt all data transmitted between locations, protecting business information from interception. The VPN allows centralized management of multiple cafe branches while maintaining security.
Next, I explain the proposed physical network diagram for Smart Cafe. So, at the top of the diagram, the network uses Unified Fiber as the primary internet connection and the Secom 4G LTE as the backup connection. So, both are internet connection are connected to the 40-gate 100F firewall. The firewall provides security, load balancing, and automatic failover. If the primary internet connection fails, the backup connection can be used to reduce network downtime. Next, the firewall is connected to the two-stack Cisco catalyzed 9300 core switches through a 10 gigabit Ethernet uplink. The core switch acts as the central connection point at the headquarters and distributes the network connectivity to the different network areas. As shown in the diagram, devices are separated based on their function, including POS system, staff devices, customer Wi-Fi, CCTV system, kitchen and online ordering devices, and management devices. For the branch location shown in the diagram, each branch has a router and an access switch that connects a local POS terminal. Wi-Fi access point and IP CCTV cameras branch A and branch B are securely connected to the headquarters through IPsec VPN tunnels. Overall, the physical network are designed to suitable for smart cafe because it provides a more organized and centralized network structure. The use of dual internet connection improves network reliability, while the structured design makes network management and future expansion easier. Next, I will explain the inter-networking devices selected for the purpose Smart Cafe network. First, the Cisco ISR1100 series is selected as the branch router. It connects the branch network and support the IPsec VPN communication between the branches and headquarters. This provides secure and reliable communication between Smart Cafe location. So next, the FortiGate 100F is used as the main firewall at the headquarters. It provides network security features such as IPS, IDS, and web filtering. It also manages the dual internet connection and support automatic failover to reduce network downtime. For switching, two Cisco catalyzed 9300 switches are stacked as the layer 3 core switch. They provide centralized connectivity and inter-relay routing. So the Cisco catalyzed 9200L is used as the access switches and support VLAN tagging and PoE plus for wireless access points and IP CCTV cameras. For wireless connectivity, the Cisco Meraki MR46 is selected because it supports Wi-Fi 6. This provides better wireless capacity when many customers and staff connect during peak hours. Lastly, the application and database server provides centralized business service, while the NVR store and manage CCTV recordings. Overall, these devices are selected based on Smart Cafe requirement for security, network reliability, centralized management, and future expansion.
Now, let's move on to the LAN technology used in our proposed network. For Ethernet connectivity, we are using Gigabit Ethernet 1 Gbps for any devices such as post terminals, staff tablets, CCTV with cameras, and wireless access point. To ensure sufficient bandwidth between network devices and prevent congestion, 10 Gigabit Ethernet is used for switch uplink. To To address the security concerns in the current network, we are implementing virtual local area network VLAN to segment and isolate different types of traffic. Our design includes 6 VLAN, each serving a specific purpose. VLAN 10 is dedicated to POS system, ensuring a secure payment processing and protecting sensitive transaction data. VLAN 20 is used for staff devices supporting day-to-day business operations and internal communications. VLAN 30 is assigned to customer Wi-Fi, providing internet access for guests while remaining completely isolated from internal business resources. VLAN 40 is reserved for CCTV surveillance systems, allowing security cameras to operate on a separate network segment. VLAN 50 supports kitchen systems and online ordering service, ensuring efficient communication between order processing and food preparation systems. Finally, VLAN 16 is dedicated to network management, providing secure administrative access for authorized IT personnel only. So by separating traffic into these VLANs, the network becomes significantly more secure as customer devices and other non-critical systems are prevented from accessing sensitive business resources and internet operations. By implementing VLAN provides several important advantages for the network. From a security perspective, VLAN prevents customers and unauthorized users from accessing sensitive systems such as POS terminal and CCTV devices. In terms of performance, broadcast traffic is confined within each VLAN, reducing unnecessary network congestion and improving overall efficiency. For flexibility, network changes can be made through software configuration rather than requiring physical recabling, making administration much simpler. From a scalability standpoint, additional VLAN can be created as the business expands, allowing the network to grow without major infrastructure changes. In addition to VLANs, we are also implementing Power over Internet Plus (PoE) technology. PoE Plus enables both data and electrical power to be transmitted through a single Ethernet cable. This technology will be used to power devices such as CCTV camera, wireless access point, and future network connected equipment. The key benefit of PoE Plus include eliminating the need for separate power outlets near the devices, simplifying installation, reducing cabling costs, and enabling administrators to remotely restart devices when troubleshooting is required. Now, let's talk about remote access. Remote access is essential for smart cafe. Store managers need to monitor operation off-site, IT staff need to troubleshoot remotely, and authorized personnel need access to business systems from anywhere. A VPN creates secure encrypted tunnels through the internet. We are implementing 2 types of VPNs. Remote access VPN connects individual users like managers and IT staff from home or offsite. Site-to-site VPN connects branch offices and headquarters through dedicated gateways. Here's a comparison of the 2 VPN protocols. IPsec VPN works at the network layer. It's best for site-to-site connections with high throughput and strong security, but it requires client software and can have firewall issues. SSL VPN works at the application layer. It's best for remote access. It's browser-based with no client software needed. It works well through firewalls using port 443 and provides granular access control. For Smart Cafe, we are using IPsec VPN for site-to-site between branches and headquarters, and SSL VPN for remote user access for manager and IT staff. These 2 diagrams illustrate our proposed VPN solution, which consists of both site-to-site VPN and remote access VPN technologies. For site-to-site connectivity, we are using IPsec VPN tunnels to securely connect the HQ with each branch location. These tunnels all provide an always-on, encrypted connection between sites, ensuring that data can be transmitted securely across the internet. This approach also supports future expansion and enables centralized management for all branch networks from HQ. For remote access, we are implementing an SSL VPN solution. This allows store managers and IT personnel to securely access the network using a standard web browser, eliminating the need to install additional client software. SSL VPN also provides granular access control, ensuring that users can only access the systems and resources necessary for their specific roles. So by combining IPsec VPN for branch connectivity and SSL VPN for remote users, the organization gains a secure, scalable, and easy-to-manage solutions that meets all remote connectivity requirements while maintaining strong security and user convenience.
Next, I will explain the wireless technology that we use. Wireless connectivity supports both customer internet access and staff mobility throughout the cafe. Our solution utilizes Wi-Fi 6 through Cisco Meraki MR46 access points. We selected Wi-Fi 6 for several reasons. First is high device density support. Cafe can have dozens of customers and staff simultaneously connected. Wi-Fi 6 handles this density much better than previous standards. Second is MU-MIMO and OFDMA. These technologies allow multiple devices to transmit simultaneously, reducing delays and improving efficiency in crowded environments. And lastly, it enhances security. We implement WPA3, which provides stronger encryption and protection against password attacks. So here is our access point placement plan. The main branch requires 6 access points in total. 4 in the customer area for coverage, 1 in the staff office, and 1 in the kitchen. Branch A and Branch B each require 2 access points. Future cafes will need between 2 to 4 access points depending on the size. All access points are ceiling mounted for optimal coverage and are centrally managed through the Meraki Cloud dashboard. Moving on to one technology, we identify a key problem where a single internet connection represents a single point of failure. To address this, we designed a dual WAN architecture using 2 independent ISPs. Our dual WAN design includes primary WAN, which is Unified Business Fiber at 500 Mbps, HQ supporting daily business operations, cloud post system, and online ordering. Secondary one is Celcom Business Broadband at 100 Mbps, serving as a backup link. The firewall automatically monitors the primary connection. If it fails, all traffic is instantly redirected to the backup without manual intervention. This significantly reduces the risk of revenue loss, operational downtime, and customer dissatisfaction from network outage. Moreover, the WAN redundancy design provides significant business benefits. Firstly, in terms of business continuity, critical services can remain operational even during ISP outage. Other than that, customer satisfaction, guests can continue enjoy internet access and orders can still be processed. In terms of revenue protection, post-transactions can continue without being interrupted, preventing lost sales. Lastly, operational efficiency, staff can continue working without disruption. For a cafe where every hour of downtime means lost revenue and dissatisfied customers, this reliability is essential.
Next, I will explain the proposed network security for the smart cafe. The existing flat network creates a security risk because customer devices may access internal business system. To address this problem, several security controls are proposed, including firewall security, VLAN, segmentation, access control list, wireless security, and VPN connection. First, the FortiGate 100F is used as the main firewall to monitor and control incoming and outgoing network traffic. It also provides security features such as IPS, IDS, and web filtering to reduce network security threats. Next, VLAN segmentation is used to separate devices based on their function. Access control lists or SCLs are then used to control communication between the VLANs. For example, customer devices in VLAN 30 are allowed to access the internet but they deny access to internet networks such as POS, staff, and CCTV system. This table shows the proposed access control between the smart cafe VLANs. The main security rules focus on the customer Wi-Fi network. Customer devices in VLAN 30 are allowed to access the internet but are denied access to all internal VLANs. Other network segments are only allowed to access the resource requirement for the operation. For example, the CCTV network can communicate with the NVR, while the kitchen and online ordering network can access the application server. For wireless security, the cafe staff network use WPA3 enterprise with user authentication, while the cafe guest network is isolated for internal system. IPsec VPN is also used to encrypt communication between the headquarters and branch locations. while SSL VPN provides secure remote access for authorized users. Overall, the proposed security design reduces unauthorized access and protects smart cafes' internal business system and data. I will explain the proposed network management for Smart Cafe. The existing Smart Cafe network has no centralized network management, which makes network monitoring troubleshooting more difficult, especially across multiple locations. The proposed network uses a centralized management approach. The Cisco Meraki dashboard is used to manage and monitor the Meraki wireless access points. The network administrator can view connected devices, monitor wireless usage, and manage wireless configuration from a center platform. Network monitoring is also used to observe device availability, network traffic, and bandwidth usage. This helps the administrator identify network congestion or connectivity problem, especially during peak hours. Configuration backups and regular firmware updates are also proposed to improve network reliability and security. Firmware updates should be scheduled outside peak business hours to reduce disruption to cafe operation. For fault management, network administrators can review device status, network logs, and security events to identify and troubleshoot network problems. The dual ISP design also provides automatic failover if the primary unified fiber connection becomes unavailable. Overall, the proposed network management approach improves monitoring and troubleshooting while supporting the future expansion of Smart Cafe.
To conclude, Smart Cafe currently operates across 5 locations and is planning to expand by an additional 3 branches within the next 18 months. However, the existing network faces several limitations, including a flat architecture, a single point of failure, shared Wi-Fi access, and slow performance at the post system. To address these challenges, we propose a solution based on the Cisco hierarchical network model, enhanced with key technologies such as VLAN segmentation, dual ISP redundancy, secure VPN connectivity, Wi-Fi 6, advanced security controls, and centralized network management. All project objectives have been successfully achieved. First, security is ensured through VLAN segmentation, access control lists, firewalls, and WPA3 encryption for wireless access. Reliability is achieved through dual ISP connectivity with an uptime target of 99.9%, reducing downtime and improving service continuity. Performance is enhanced through quality of service (QoS), which prioritizes critical post traffic and to ensure fast and reliable transactions. Scalability is supported by the hierarchical design, allowing the network to expand smoothly as new branches are added. Manageability is improved through centralized cloud-based management, enabling efficient monitoring and control across all locations. So overall, this design provides a secure, reliable, high-performance and scalable network infrastructure that supports both current operations and future growth. Finally, our recommendation: first, implement the proposed design. Second, use a phased rollout, starts with HQ, then branches. Third, provide staff training on management tools and security. Fourth, ensure regular maintenance for optimal performance. Fifth, leverage the modular design for future expansion. So in conclusion, this network design provides a robust, secure, and scalable solution that addresses all current weaknesses while positioning Smart Cafe for future growth. It resolves security, reliability, and performance issues. It supports 3 new locations within 18 months, and it ensures consistent service quality across all branches. That's all from us. Thank you.